Alright, so we've looked at some really simple coding, we've looked at some string functions, is what we've looked at a lot, making some of our own functions. So pretty much what I was trying to do is, what I was doing over the past few days was getting a basic understanding, super basic, of how to construct a language, how to use the language, basic words, so basic operations and whatnot. So now I figure it's time to start learning what some of the fundamental data structures are. The data structures are the tools that we'll typically work with most of the time to get things done. So it's really important to understand how they work. So one of the most important ones is the list structure. So the documentation states that the list is the most versatile data structure that there is in Python. So pretty much I figure we'll do data structures one at a time. So yeah, let's just dive right into this. We'll see how lists work. So lists are, we've already seen them actually in past videos, but we didn't really talk further about them or dive into them, so it shouldn't be too unfamiliar. Lists are fundamentally a sequence type, so they have some of the same behavior as strings. So if I say I have something in string, I have a string called banana. If I do indexing, I can refer to some individual character within that, or I can refer to multiple characters. And so the same thing applies to lists. So lists are defined with square brackets and elements are separated by commas. So if I just make a little list here, then I can call individual elements. And again, indexing starts with base 0 and can have negative numbers just like strings could. So see how, because it's a sequenced data type, sequence is present, you can use indexes to refer to individual elements. To make an empty list, you just use empty square brackets. And if we print that out, we see it's just empty square brackets. So that's notable that it's different from a list containing an empty object or something. So for example, I'll just take the length of ls, and we see that the length is 0. And that's because ls is an empty list. But if I had ls was equal to an empty string, a list containing an empty string, see that the length of ls is 1. And that's because it has one element. That empty string is still a string, and so it has one element. So alternatively, instead of just defining it as an empty list using square brackets, you can use the clear method. So let me just say ls has one element in there, and it's just a 1. Now my ls is a list with one item, it's a 1. Or let me just actually make that even longer. ls equals 1, 2, 3. Now if I use the clear method, that becomes an empty list. So methods are functions that are applied to particular objects. So you might say that the objects own the function. So for example, kind of thinking abstractly outside of the space of our computer code right now, if we think about a car as an object, a car has methods, so things that can be done to it or that it does. So we could say car.drive. So we can say that our car has a drive method. And then you would want to pass an attribute maybe. So maybe your attribute could be style. So the style is the input to the driving method. And we could say style would be aggressive, for example. So that's kind of the general construction. You have an object, and then a period, and then the method, name, and then open brackets, and the stating of any method arguments for the method if there are any. So coming back to lists, a very useful thing you can do is identify all the methods for a given object using the dir function. So you type dir and then pass in a single object, and this will give you a list of all the methods for that object. So some of them have underscores beside them. Those are kind of groundwork Python methods. Those methods facilitate various things that the language does under the hood. You can use those methods as well. They're perfectly good to use. They have particular functions, as is kind of indicated by the name. But in very common usage, you might be more so using the other methods that don't have the underscores beside their names. So, for example, just to show a different example, if I type in dir and I'll just pass in a single letter, so that's a string, we see now there's all these methods for strings. Partition, replace, split, starts with, strip, swap case, title, etc., etc., etc. So you can use that dir function to return a list of all the methods that an object can have. So clear was one of those methods for a list, as we just saw, ls.clear, and that takes no arguments. So when a method takes no arguments, you're going to want to just put empty brackets after it. The reason for that is because if you just type the function without brackets, what you're returning is actually the function, the method itself, as an object. So what that means is that you can manipulate that object and do things with it. So for example, you can store it somewhere. So lists, something I forgot to mention is that they can store data of various types. So I can say ls equals 1 a string. String was a variable containing a string. And I could even say len and clear. So say ls.clear. So you need to use the dot to specify that it's a method and not a variable. So now I have a list which contains an integer, a letter, a string, a function, and a built-in method of a list object. So you can see how when you refer to methods and functions by just their name, they behave like as if you're manipulating them as an object unto itself, and you can store them in such things. So maybe I can call ls and the method is in index number 0, 1, 2, 3, 4. So if I do 4, I don't know if this is going to work, but I'm wondering if we can evaluate that method by adding brackets here. So it didn't actually clear. Let me try this. Print ls4. So I'm calling so if I print this, it's just printing the method. Now if I add those round brackets, it returns none. Interesting. So maybe I can say this ls, new ls, or cleared ls equals ls4. Well, that would just return none, I think. ls4 round bracket cleared ls is none. Anyway, so I'm not sure actually. I'm not sure. I could do further research to find out how you would evaluate a method once you have it in here. In any case, I figure we can move on to some of the, just finally, one of the last things about subindexing. So if you have a element in your list that has indexing within it, you can reference that, the sub-element. So banana is index number 2. And if I type in index, if I do a slicer here, I'm actually pulling out that sliced. That slicer is referring to the object that is returned by the second element, the second index of the ls list. So you see how I'm pulling out data from within the list. And you can layer this even further. So let's say ls was a list of lists. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have a list of lists. So for example, you could say, you could even go further. So you could say ls1 equals ls and another list over here. Now you see ls1, I have a list within a list within a list, I think. So I could do ls1 0 to pull out this larger one, and then I could pull from there 0, which will pull out this first list, which has 1, 2, 3 in it. And then I could say 2, which is going to go to index number 2. So I'm expecting this will return a 3. And it returned a 3. So you can do this with as much nesting as you like. Alright, so just moving into the methods, you're going to need basically to be familiar. It's important basically just to know what tools are available to you when you're working with these things. So we can just run through those relatively quickly, and we'll be using them, I'm sure, in the future. So one of them is the remove method. So if I do ls1.remove, you can pass an element, an index in. So I could say index 0, and that will remove. Oh, I thought it would. Never mind. I think you just pass in an element. So if I do ls.remove, and I'll just say a b, because this element exactly matches this one over here, it gets removed. Oops. So now we saw how that AB list, which was in here, was removed. So this method goes through your list and finds where that element is, and it just removes it. So another thing you can do is insert. So if I do let me just see what's in ls. I have this. Okay, so let me just make this something simpler. 1, 2, 3, 4. Now my list is just 1, 2, 3, 4. You can use the insert method, and you're going to specify an index value where it can be inserted. So I'll just say 0, and then what's to be inserted, I'll just say A. Oops, should have been a round bracket. So now you can see that index 0 now has an A. And you'll notice that this is not destructive. It doesn't overwrite your data, it just pushes everything aside wherever it might need to go. So for example, if I just put 3 here and put B, now we see that those things to the right are just moved over, and B is in index number 3. So beyond that, another way to add things is the append method. The append method adds an object to the end of the list. So for example, let me just try something. Let's see if we could do that with the insert method. So we know here that there are 0, 1, 2, 3, 4, 5. There are 6 items in this list, so the highest index is index 5. So if I try to go to index 6, which doesn't exist, let's see what happens. Alright, so you can add data to the end of your list using insert and specifying the highest index plus 1. Now I'm curious, if I skip one, what happens? I think I didn't skip by accident, so let me say ls equals 1, 2, 0, 1 rather. So those values in ls now correspond to the indices. So let me say 3, insert 3, 3. Oops. Round bracket ls. So it looks like when you use the insert method, if you specify a number greater than the number of indices available, it just tacks it on to the end. So let me try that again. Insert, I'll just say go to index 1000, or I'll just try 10 instead of being so extreme. Say insert new. And we can see, alright, so that's how the insert function works. If you specify an index greater than that which exists, it just gets tacked onto the end. So what the append function does, so now let me just do this, ls.remove new. So what the append function does is it appends an object to the end of your list. So, for example, I could double this up, or rather I could nest it within itself. Let me say, what's ls1 again? ls1 is very large and ugly, so I don't want to do that. Let me just work with ls. I can say ls.append, and I'll pass in itself. Now what happened is that it has itself in there. I'm surprised to see it's a dot dot dot. I haven't seen that before, so I'll have to do some research to see what that means. Let me try with a different one. I'll do ls1. I'll overwrite that be equal to a b. Now I do ls.append. First of all, I'll just say ls equals 1, 2, 3. And now I'll do ls.append and append ls1. Now if we see ls, now we see that we went from a list of having just 1, 2, and 3 to having a list that has 1, 2, 3, and another list inside of it. So whereas insert, just insert a single number or something, you can use the append method to pass an object. And that's a really important distinction from the next one, which is the extend method. So if you use extend, so I'll do ls.extend and pass in ls1, what happens with the extend method is that you're passing in something that can be iterated over, such as a list. And instead of inserting that list in its entirety as a distinct element, it inserts each element from that list. It iterates through it and it inserts what it saw as elements within our main list we're talking about. So the append method will increase your list size by 1, your length, whereas the extend method will increase your list length by the number of elements in the thing you extended by. Really important difference. Then there's the reverse method, which just reverses your content. So let me do ls.clear, ls.extend by words and characters. And so using the extend method with a string, it iterated over the string and created a list with all these different characters as their own elements. So another thing you can do is you can use the pop. You can use the pop method. So what that does is it takes a function out and returns it at the same time. It doesn't return it to the list, but it returns it to you using the assignment operator. You can put it in a different variable to work with it. So for example, if I say ls1 is equal to a list within a list, a two lists within the list. If I use the pop method, I'll say popped equals ls1.pop, and then you pass in an index value. So I'll say index 0. It's going to be the first one. And now if I type in ls1, I see the first element was removed, a and b. And if we print out pop, we actually see that that was passed into pop. So the pop method just pops one out for you. The sort method sorts your data. So if we do that on ls, which is characters, do ls.sort, you can see that now it has been reoriented. The spaces come first, and then all the A's, C's, D's, etc. And that has a couple of important optional arguments. You could do sort, and then you could specify reverse equals true. And if you specify that, it reverses the sort order. I can do that. Now if I just do sort once again, it brings it back to regular order. And so that's basically the default order is lowest to highest, and the reverse order is highest to lowest. And you can also sort using a key. There's an optional parameter which is the key. So I'll show you how to do that. Let me just first reverse this. Reverse equals true. So what the key does is it allows you to enter a function by which all these parameters will be evaluated, and and sorted according to the evaluation within that with that function. But what it did is it just returned it back to regular order. So here's why. The ORD function, which I passed in, it gives you, if you pass in a string to the ORD function, it gives you the ASCII code corresponding to that string. You can see that the alphabet goes in sequence from 97 for A, and then up from there. 97, 98, 99, ABC. So by passing the ORD function in to the sort key, what I was saying was look at each one of these elements, pass them into the ORD as an argument, and then sort based on the outcome. So instead of sorting by A, B, C, etc., what really it sorted by was 97, 98, 99, etc. So you can use this with whatever, really any function. I think so far as it maybe gives us something that's sortable, such as letters or numbers. So you could pass in, for example, length of, if you had indices, lists in here. Let me try that. Let's say multi-list equals, I'll make a list within a list, which has 1, 2, 3 elements. So I'll just put 3, 3, 3. And then I'll make another list in there, which has 1, 1, 1, or just 1 actually. And then I'll make another list that has 2 elements. So now, if I sort, if I do multi-list dot sort, and I make my key equal to len, now it should pass each one of these lists through the length function and sort it by the outcome. So what I'm expecting to see is that it goes 1, 2, 3. 1, 2, 3, right? So the list with just 1, 1 in it gave an outcome of 1. And this list, when passed through the sort, the length function, gave 2. And then this list gave 3. So it sorted them based on that number. Alright, so moving on from there, there's a function called sorted, which is also relevant. So you'll notice if I just do multi-list, if I just do ls.sort, I need to add the brackets so it evaluates, it returns none. The fact that the prompt went to the next line without showing anything means that the function returns none. It doesn't return anything, it just transforms the list. So there's a different function, which is not a method, but it's a function, which is sorted. The sorted function takes in a list, it returns that list sorted. So it has the same arguments as the sort method, except it has the additional argument of the list that you're sorting. So here's an example of using this. Let me say I did ls.sort reverse equals true. I have my LS's backwards. Now what I can do is I can say my sorted list equals sorted, and pass in ls, and I won't make the reverse true. I'll just make it sorted regular. So what just happened? What just happened is that we have ls, which is still in reverse order. Now I have sorted list, a different variable, which is in regular order. So where the ls.sort method transforms your ls object, as we just saw right now, it just sorted it. Whereas that transforms the object that you're applying the method to, the sorted list function doesn't transform the object that it works on. I'm just surprised to see this call, but we'll leave it. It doesn't transform it, it just returns it. Oh, I know why. I think I know why that just happened. Because I did sorted list as a function. Sorted. There we go. So it returns it. So that's a really important difference. So finally, we'll just close off with two really quick methods of the list, which is, one is the index. So with the index method, what you can do is ls.index, and it returns the index of an element you pass in. So let me say I put in O. It returns 12, and that's because the O, which is right here, is 13th line. So 0, 1, 2, 3, 4, 5, 6, 7. Oh, I'm looking at the wrong output. I was looking at the sorted output. So ls is over here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's index number 12. So the index method returns the index for element you enter. And the count element method, so I could do ls.count and then pass in an element. Let me do d. Counts how many times that element appears in your list repeatedly. So note that that's not the count of how many elements are in the list, just how many, a total I mean, but just how many are there of that particular one you enter as the argument. If you wanted the count of how many total elements are in the list, you'd do the length function. So I'll leave it there for lists. Super important to understand them inside and out, and how these methods work and how you can use them to your benefit. So thanks for watching, and support me on Patreon if you like, and you can find my cheat sheet summary document on GitHub. Thanks for watching.